there. In today's video, we are going to go through a couple of half-life examples. So, in half-life examples, there are 3 steps. Step 1, find the decay constant. Step 2, write the function. And step 3, solve. So, keeping those 3 steps in mind, we're going to read this problem, and we're going to figure out how to solve it. Plutonium-239, Pu-239, has a half-life of 24,110 years. How long does it take a 1 gram sample of Pu-239 to decay to 0.1 grams? So, our first step is always to find that decay constant. But even before we do that, let's write down the equation that we're going to use. So we're going to use our decay constant equation, which is N of T equals N naught E to the negative KT. So that is the equation that we're going to use. And this equation, N naught, stands for our initial amount. E is just the natural number. K is the decay constant. And T is the time. So now that we have that equation down, let's work through this problem. So step 1, find the decay constant. Okay, how in the world do I find the decay constant? What do I do here? Well, I know that it takes plutonium-239 24,110 years to get to half of its substance. And then I have 1 gram, and I want to see how long it takes to get to 0.1 grams. And so really, to me, it seems like we have 2 completely different things here. We have this piece of it, which is telling us about the half-life, and then it seems like we have a second piece down here, which is saying we have a certain amount that we're starting with. How do we get to the final amount? So we've got 2 separate things going on. Use the half-life to find the decay constant. So I'm going to write that on here just so you know. Use the half-life to find the decay constant. Okay. So we're going to use the half-life to find the decay constant. Well, what do we know? We know that it takes 24,110 years to get exactly half of the substance. It doesn't really matter what we start with or what we end with. We know that we're going to have half. So what that means is I can set up this equation saying 0.5 equals E to the negative K times 24,110. Now you might be asking yourself, what happened to the N naught, Mrs. Roberts? Well, think about this. We have 0.5 right here. So it's kind of like we have a little ninja 1 here. And it's like our N naught was 1, and we ended with 0.5. But because this is 1, we don't actually have to write it there. 1 times anything is that anything. And so that's what happened to the N naught. It's just 1. Now we're ready to solve. So what we're solving for is we are trying to get this K. Just the K. And so if we're trying to get K, how do we cancel out the E? Because I can't get K out of the exponent until something else happens. Oh, E is just the natural number. So if I use the natural log, pen's not working very well. Let's try a different pen. So if I use the natural log, that will cancel out the e. And what I'm left with is what's in the exponent. So that means that ln of 0.5 equals negative k times 24,110. How do I get k by itself? If I just want k, I'm going to divide by negative and 24,110. This is when you have to start using your calculator. So we know that k is going to equal this. I'm going to take my calculator. The ln button is right here. ln 0.5 divided by negative 24,110. Here's my decay constant. My decay constant is 2.87493646646 e to the negative 5. What does that e to the negative 5 mean? What it means is to pick up your decimal and move it left 5 spaces. And so what I know is that k equals 2.875 times 10 to the negative 5. But really that means take this decimal and move it. And so I'm going to have 0.1234. That is what my decay constant is. That is what we replace the k with in this function. Now all we've done so far is found our decay constant. Before we get too far, I want you to take your calculator and I want you to store this value. If you use a rounded value, you're not going to get the exact answer. And so this STO with the little arrow button, that means store. So go ahead and click that. And then you could put this in any letter that you want. I want to put it in K, because we're going to use it for K. So I'm going to hit alpha, and then right above that parenthesis is a K. And then I'll hit enter. And the really cool thing is every single time I hit that button now, it is going to be, oops, that's an F. It is going to be that number. So I have it stored in my calculator. We have finished step 1. Step 2. Write an equation. Put the steps in a little box so you know where to find them. So we have this up here, and I'm just going to go ahead and highlight things so that we know what we're going to be using. This is K, so this is what's going to replace K in the equation. And this is N naught, that's our starting amount. And let's use one more highlighter color. This is our ending amount right here, and this is our ending amount. So it seems like I can fill everything in except for T, which means I could solve this. So I'm going to have 0.1 equals, and that came from pink, 1, of course we don't have to write that, times e to the negative 0.0002875 times t. And our very last step is to solve. So I'll write that over here. Step 3, solve. We have this equation here. We only have one unknown. We can solve this. How do you get t out of the exponent? Oh, we ln both sides. This cancels out. You're left with ln of 0.1 equals negative 0.0002875t. To get t by itself, divide by this number. And that we do on our calculator. So we'll take our calculator, and we have ln 0.1 divided by negative k, because we don't have to put that in there, we have it saved. Oops. And so t equals 80,091 years. And we've solved it. There we go.